Hey guys, welcome to Safi Mixed. In this video, I will let you know how to plot conditional equation in Mathematica like the one you see on the screen. So let us understand how can we do this in Mathematica. Conditional equation can be plotted through different approaches in Mathematica. However, here I use the f function. So let us first understand what the f function is. The f function takes three entries in its arguments. The first entry defines condition on a variable. If the condition on the variable stands true, the f function evaluates the second entry, which here I denote with f. And if the condition at the first position is not true, the f function evaluates the third entry, which I denote here with g. With that said, first I split the given conditional equation into two parts. The first part, which is 6 times exponent minus a times x, I assign to f1, and the second part of the conditional equation, which contains sine function, I assign to f2. If I run this part, then I construct the f function, which I assign to fx, and inside the f function at the first position I define the condition over the parameter x, which says that x is greater than 0 and lesser or equal to 3. Now, when the value of x lies between 0 and 3, the f function will evaluate the function f1. And if the value of x is out of this region, that is, it is either greater than 3 or lesser than 0, the f function will evaluate function f2, which is the sine function. If I run this and I want to plot function fx now through the plot command, which I am putting over here, and I put the value of parameter a in f1 at this position equal to 2, and the value of parameter b at this position I set it equal to 10, and I plot the function fx for x running from 0 to 6. Then I add another command, plot style, and I write inside the argument red, which stands for the color of the plot, and thickness, which I am setting equal to 0.01. If I run this, I get this behavior of the function, which is exactly as per the condition given in the f function at this position, because in this region from 0 to 3 the f function evaluates f1, and f1 is an exponentially decaying function, which is shown over here. This is exactly an exponential decaying behavior, and for x greater than 3 the f function evaluates f2, which is sinusoidal at this position. So we get a sinusoidal varying behavior in this region. Thank you very much for watching. If you like the video, do subscribe to Safi Mix and press the like button.